I'm going to take you through the printouts of the slides that we did during class. And part of that is just reviewing some steps for solving linear equations. So we'll go through the warm-up real quick because that's part of those steps. Actually, just kidding. I'm going to go ahead and go to those steps first. So you ought to pause and write these down. The first is to distribute and simplify by combining like terms on both sides of the equal sign. Right here, do not cross the equal sign. That part is very important, that you don't combine like terms that are not on the same side. So once you have distributed and combined like terms, you take away the smallest variable from both sides of the equation. If you can get in that habit, it doesn't have to be your next step, but it's the easier step to keep your variables from becoming negative. And when you're dealing with inequalities, like we will in this section, it gets a lot easier to not have to deal with negatives. Next, you add or subtract to get the constants to the opposite side of the variable. And then you multiply or divide to get the variable alone. So those are your basic step-by-step directions for getting through and solving linear equations. Now we're going to move on into solving linear inequalities. So if I have these inequalities, and I want to just clarify what all these are. This is opening up, the arrow is opening up to the 6. That means that the 6 is bigger than x. The other way to put that is less than 6. So on that notion, same idea. This one is opening up to the x, which means x is greater than 6. But now we also have this line underneath it that says or equal to. The difference between having that line, the or equal to, and not, is that that changes what x can be. In this particular case, x cannot be 6. So x is less than 6, so it can be everything up to 6, but it cannot be 6. With this one, x being greater than or equal to 6, that means 6 is in that solution set. So those are my, just in words, what these mean. X is less than 6, x is greater than 6. This here, it's open to the x. Here, it's open to the 6, or it's pointing to the x. So there are a couple ways that people remember that. It just depends on what works for you. When the line's under it, x is greater than or equal to 6. In this case, x is less than or equal to 6. What that looks on a number like on a number line, I'm always going to put 0 and then my numbers reference to 0. So 6 is obviously bigger than 0. So for x, I'm going to put a parentheses right here and point everything below 6 because x is less than 6. So x cannot be 6, but it can be anything underneath it, anything less than that. With x is greater than 6, I'm simply pointing that in the other direction. My parentheses and everything greater. This parentheses here and here, that indicates that 6 is not a value for that solution set. On this one, I have 0 and I have 6. And instead of a parentheses, because x can be 6, I'm going to put a bracket and then my arrow going out in that direction. Same thing on the other one. I have 0 and I have 6, bracket at 6, and then an arrow going down because s is less than or equal to 6. So now when we get into solving linear inequalities, it's nearly the same as solving equations. If I have the equation x plus 3 equals 8, then I need to get the x alone by using the opposite of addition. So I subtract that 3. That gives me 0, so I have x alone, or x plus 0, which is just x. And then 8 minus 3 is 5. So that's my answer on that one. In this particular one, on the inequality, so this is an equation because it has an equal sign. This is an inequality because it has a less than, greater than, less than or equal to, or greater than or equal to sign. This one has a less than sign. This is saying x plus 3 is less than 8. So I'm going to do the same thing. Subtract 3 from both sides, so x is less than, just bring that sign down, 5. So what that means, if I plot it on a number line, I have 0, I have 5. X can be anything less than 5. So I'm going to put a parentheses and point down. And you can always check and see if that's right or not. If I put 5 in my equation, that gives me 8 on this side. 8 is not less than 8. So that one would not work. That's why I have the parentheses at 5. If I put something in less than, and 0 is always a good thing to check, if I put something less than 5 in for x, 0 plus 3 is 3, which is less than 8. So that's how I know everything below 5 is going to work. So that's just a way to check whether or not you're correct. Just a couple of more basic examples. This x over 6 is x divided by 6. So x divided by 6 equals 12. So to solve, I undo that division by multiplying. Multiply both sides by 6. 6 divided by 6 is 1. So I have 1x, which is really what I want, is just x by itself. And then 12 times 6 is 72. If I have the inequality, again, I'm going to multiply by 6. And I have x, just x, because my 6's divide out. X is less than 72. So then on my number line, it's really just reference to 0. I don't need to worry about scaling. So x can't be 72, but it can be anything under it. I have some more in-depth ones. I'm going to use those same steps that I had you write down a few slides ago. This one only has x's on one side of the equation, so I can skip to adding or subtracting to get my x's alone. So I'm going to subtract the 6. I have 3x is greater than or equal to 4. And then divide or multiply. So divide to get x completely alone. So x is greater than or equal to 4/3. If I look at that on a number line, I'm going to go below here. If I have 0, 1, and 2, 4/3 is going to be 1 and 1/3, so I'm going to be right around here. This is a greater than or equal to, so I'm going to put my bracket around there and go upward from there. So that's approximately 4/3. On the next one, I do have x's on both sides. There's no simplifying to do because 4x and 8 are like terms, and 2x and 12, negative 12, are not like terms. Can't combine them. So what I need to do is get all my x's to one side and all my numbers to the other. So the next step on our list is to take the smaller variable away from both sides. So I'm going to subtract 2x. So 4x minus 2x is 2x. Drop down, plus 8 is less than or equal to, so drop that sign down as well. And then I have negative 12 left over here. The next thing is to add or subtract to get the constants to the opposite side of the variable. So I'm going to take away 8 from both sides. So I have 2x is less than or equal to negative 20. And then I divide to get rid of the 2. So x is less than or equal to negative 10. So in reference to 0, I have negative 10, and x can be anything less than or equal to negative 10. A couple more examples. Smaller of the two variables again, negative 7x, or minus 7x, so 15 is less than or equal to 6x plus 51. Subtract the 51 to get the x by itself, so negative 36 is less than or equal to 6x. Divide by 6, and I have x is greater than or equal to negative 6, otherwise known as 6 is less than or equal to x. Over here, we have a more in-depth problem, so I'm going to start by distributing. 2 times x is 2x. 2 times negative 3 is negative 6. Drop down the plus 5x. Greater than or equal to. Distribute over here, so I have 8x minus 8. And then I need to get my x's to one side and my numbers to the other. So I'm going to take away the, I'm going to simplify first. So by combining like terms, so 2x plus 5 is 7x. Drop down the minus 6. Greater than or equal to 8x minus 8. Subtract the smaller of the two variables. So negative 6 is greater than or equal to 1x minus 8. Add 8 to both sides, and I'm left with 2 is greater than or equal to x, or 1x, which is what we're going for. So it's the same steps as solving linear equalities, but something comes into play here. So I want you to look at these two examples right here. I have 2x is greater than 10 and negative 2x is greater than 10. Divide both of these by 2 and I get x is greater than 5. So I have my 0 and I have 5 and x can be anything more than 5. So if I pick some number up here that's greater than 5, let's say I pick 20, because it's definitely greater than 5. If I put 20 in for x, so 2 times 20 is greater than 10, then I get 40 is greater than 10. And that's true. That works. So I know I have my solution set okay here. Over here, if I divide by a negative 2, then I have x is greater than 5. Or sorry, negative 5. Now, if I look at a number line there, so I have negative 5 and I have 0, and x can be anything greater than negative 5. Something is amiss, because if I take 0, which is greater than negative 5, and I put it in for my equation, so negative 2 times 0 is greater than 10, then I get 0 is greater than 10. Whoops. And that's not true. 0 is actually less than 10. So what happens, this is not correct. If I look at it in a different way, I'm going to keep my sign the same. So I'm going to scooch this over here. So if I switch this, negative 2x is greater than 10. And I want this to be a positive 2x. I'm going to add 2x to both sides. So I have 0 is greater than 10 plus 2x. And then I take away 10. So negative 10 is greater than 2x. Then I divide by 2. I have x is less than negative 5. So that goes in the other direction that it told me to go in initially when I divided by the negative 2. So what happens is if you divide or multiply by a negative number in order to solve for x, you have to switch the sign. So if I have negative 2x is greater than 10, back to my original problem, and I divide by 2x, not 2x, sorry, if I divide by 2, negative 2, then I'm left with x. I have to switch my sign here, becomes less than, and then negative 5. So you could take these steps that I went through over here of getting the variables positive, or you can just remember that you have to switch the sign if you divide by a negative number. So this one is x is less than negative 5. So we have a few practice problems. I'm going to do a couple of them and then let you guys work on your own. So we'll do these two, 59 and 63. So on 59, subtract 3 from both sides. 3x is less than 15. Divide by 3. So x is less than 5. Plot that on a number line. I have 0, I have 5, parentheses at 5, and everything less than 5. On 63, I add 3 to both sides, so negative 2x is less than 6. Divide by negative 2. Remember, when you divide by a negative, you have to switch the sign, so I have x is greater than negative 3. So I have 0, I have negative 3, x is greater than negative 3. And if I put 0 in there into my original, I get negative 2 times 0, which multiplies that to 0. So I'm left with negative 3 is less than 3. And that is correct, that negative 3 is less than 3. So I have my arrow pointing the right direction. So you should do 57 and 61 on your own. Pause and write those down. On the other side, when I have variables on both sides, I can avoid having to flip the sign by taking away the smaller variable. So I'm just going to do 67 and leave it at that. So if I have 2x minus 5 is greater than negative x plus 6, negative x is my smallest x, so by taking that away, I'm adding it to both sides. So I do the opposite to take it away. So plus x. That way I keep a negative x. And then add 5 to both sides. So I'm left with 3x is greater than 11. So I brought this over here. Divide both sides by 3. And I end up with just x is greater than 11 over 3. It's not a very nice one, but it works well enough. So that is section 2.6. This is the last section in chapter 3. We're going to do chapter 2. We're going to do 2 sections in chapter 3, and you guys will have your unit test. Hope you have enjoyed thoroughly linear inequalities. Have a good day.